Good morning, everybody. So today we'll see two more Turing machine designs. Okay. So let's take one question, which is design Turing machine which accepts 0 power n, 1 power n. That is equal number of zeros followed by equal number of ones for n greater than or equal to 1. Okay. So how will we do this solution? You have to remember for every, because we don't have stack etc here. So what we are going to do is, let us say you have an input like this. Okay, let us assume you have an input like this. So when I see 0, okay, when I see 0, I should remember I have seen this 0. So I'm going to replace this 0 as x. Okay, and then I'm going to move towards right side till I get the leftmost 1. So for this 0, I have found a matching 1. So I'm going to replace it as y. After doing that, I'll come back and again search for the leftmost one. If you remember, this 0 doesn't exist anymore. It has become x. So I am going to search for the leftmost 0. So again, I find this leftmost 0. How do I know this is leftmost 0? So I'll come till x and I'll go back. Okay, the next 0. This 0, I'll make it as x and I'll move towards right side till I find the leftmost one. I'm going to make it as y. So while moving back, again you see, if you get y, you move back. If you get a 0 also, you move back till you get x. And once you get x, you come back here to this 0 and make it as x. And once you get this x, you move towards right. Again, y, if you get y's also, you move towards right till you get a 1 and make it as y. Okay. If we do this equal number of zeros and equal number of ones, and we should stop when we are running out of the input, and also we should be in the final state. That is the motive that we find for design. Okay, I mean this is the logic that we are going to implement for design. So let me just write some moves here, whatever we told in English. So what are the moves we are going to design? So first one is, in the string, if leftmost symbol that we encounter, if it is 0, right? If it's 0, then we replace it by x. That's what we did here, isn't it? So after replacing it by x, what do? We move till we find the leftmost one, correct? So after you replace it by x, after this, move right side till we find leftmost one, correct? And what will you do for this one? We'll replace it by y. Replace 1 by y, and then in search of 0, what we do is we move backwards, right? We move backwards to find the next leftmost 0. So this is one thing that we should keep in mind. What about the next thing, right? What will you encounter when you move backwards? When you move backwards, we have to go and find the leftmost one and repeat this step, isn't it? So we repeat step 1 again with the newly found leftmost 0, with leftmost 0 again, correct? Right? So if we are moving back and also in the front, right? So if no 0 or 1 remains, then it is a final state. Didn't I say that here? So if all three are x and all three are y, so that means when we are going backwards and forward, we'll not have any more zeros or ones, right? So if we are moving back and also front, or you can say back and forth, and we encounter no 0 or 1, then that means we have to move to final state. Okay. Now, if at all there were unequal number of zeros and ones, then we'll find either when we are moving forward and backwards, we'll find either 0 but no 1, or we'll find 1 but no 0. Something like that will happen. Right? So for any other string which is not in that form, so for any W or for any string not in number of zeros followed by equal number of 1 form, the state has to be non-final. That means it should not be accepted. Okay. So keeping this in our mind, we are going to design the Turing machine. So let me, for this example, let us write the state transition diagram, and you know how to convert it into table. And for another example, we'll design a table and you can also convert it into transition diagram, because in exam we don't know what is asked. So we should know everything. So let us start with Q naught. Okay. So in Q naught, I told what? If you get a 0, you have to replace it with x, isn't it? If we get the 0, we have to replace it with x and we should move towards right, isn't it? And let us say after doing that, we come to state Q1, because replacement is a different thing, isn't it? In the previous class, I told you, whenever we make some major change, we are going to change the state. So say we had this, right? So I made this x and I have come to state Q1. Now I should keep on moving till I get a 1, isn't it? So that means if you get 0, what you should do? Just keep on moving. It's not a substantial change. So if at all you get a 0 after this, after coming to Q1, keep it as a 0 itself, right? And just move towards right. So in Q1, I have taken this, and I have come to 1 now. Some change, isn't it? Right? So if you get 1, suppose, if you get 1, then what did I say we should do? We should replace it by a y. So if it's 1, replace it by y, and then we start moving towards left to search for the next 0, isn't it? So it's again a substantial change. So we are going to state, let us say, Q2. All right. So let us say when you come back, you get this 0 and this 0 and this 0. You should just move left. So it's not a very huge change. So when you are in Q2, if you get 0, you are not going to make any changes. You are only going to move towards left, right? Once you move towards left, you will come to this x, isn't it? So this x will tell me the next 0 is what is to be replaced as x. So let us say if you move towards left, when will you move? You have moved towards left, and suppose you got the x. If you get x, will not make any change to that x. I'm just going to move towards right. Why? Moving towards right will bring me to the leftmost 0. And then this continues. If you get 0, now I'll rewrite this. So we are at this stage now, and I'm here, right? I'm here with Q naught. So you can see same thing now. 0 will be replaced by x, right? And you move towards right and you make the state of change as Q1. Now on 0, you'll just keep it as 0 and keep moving right. Now, I haven't written anything for Q1 on Y, isn't it? I've written for Q1 on 0 and Q1 on 1. So if you get y, what you should do, you should not change y to anything else, but you should move forward. So if I get a y, I'm going to keep it as a y and just move towards right. So now this is q1 on 1. So I said q1 on 1, replace this 1 as y. After replacing it as y, what do we do? So after replacing this as y in q1, I move to q2 and just make it a left transition, searching. Again, you can see q2 on y is not written. So if y is there, what will I do? I'll just come back, isn't it? So if you get a y, make no changes, you just move towards left. Okay. So I keep moving towards left till I get a x. Once I get x, I go to state q0. So let me write it again. Now we found twice, isn't it? So we have two x's and a 0 and two y's and a 1, and I am x and r and go to q0. So again I am at q0 here, correct? Once you are at q0 0, what will happen? 0 is replaced by x. So this becomes x and I go to state q1. q1 on y, you are not doing anything, you are moving ahead. q1 on y, you are not doing anything, you are moving ahead. So now q1 on 1. q1 on 1, you will replace this 1 as y and you are moving towards left, correct? So you are moving towards left here and the state is changed to q2. q2, y on y, you just move towards left. And q2 again y, so you move towards left. And now q2 on x, so you keep it as x and you move towards right. What is the meaning of this? Yeah, so we found equal number of zeros and ones. No more zeros are there, isn't it? But now once I find that, I have to see if there are any more ones also, because if this is the case, we'll be left with more ones than zeros, isn't it? So if I have y, now I should just move towards right side, okay, without making any changes. And only if I get a blank, after I see all y's, it means I can accept. If one is there, then I should not accept. It's not equal number of zeros and ones. So if you are in q0 and you get y, okay, why did I say if you are in q0? Because if you remember, once we are traveling left side and you get an x, you came to q0, right? And you move towards right, isn't it? After this, x is replaced as x and you move towards right. So here q0 on y, I have not written anything. q0 on x is written, q0 on 0 is written. So what will I do for q0 on y? q0 on y, we'll just keep it as y and move towards right. Okay, move towards right. So let us call it as q3. So now it becomes q3. If I get y, q3 on y also I should move towards right, isn't it? So if I get y, I'll keep it as y and move towards right. Since I am not making any substantial changes, let me keep it here itself. Okay. Now next, final state is when, if at all you reach a blank. So I'm not going to make any changes to blank. I'm just going to change my state to a final state. So let's call it as Q4. I'll write one or two examples and show you how this works out, okay? How this works out. So basically what did we do? First, if you have 0, you replaced it with x and then you move towards right. And if you get any more zeros, you just kept on moving towards right till you get the leftmost one. Once you got the leftmost one, you just move towards, made it as y and move towards left side till you get x, correct? And once you get x, you just keep it as x and move towards right. And if you have 0, then you will again start the whole process again. Okay. So let us see how this works with a small example. We can take an example here. So let us start with 0, 0 and 1, 1. This should be accepted. Okay. So you see Q naught is where I start. So Q naught on 0, or we can write this representation. Okay. So Q naught on 0. What is there? Q naught on 0 is replace that 0 by x. Move towards right to state Q1. Right? So the next will be this. Now what about Q1 on 0 after this? Q1 on 0 is just moving towards right. So since it's just moving towards right, Q1 moves right. Right? Now it's Q1 on 1. Q1 on 1 is replace 1 as y and move towards left. Change the state to Q2. So x 0, right? And this 1 is replaced by y. And Q1 was here, so you move towards left and you have Q2. So Q2 on 0, just keep 0 as 0 and move towards left. So now I have Q2, x 0, y and 1. Correct? Now what about Q2 on x? Q2 on x will be x itself. Move towards right and come to Q0. So after this I'll have x will remain as it is. Move towards right to state Q0. So I have Q0, 0, y, 1. Right? So what about the next state? Q0 on 0. We know 0 will be replaced by x. And you move right to state Q1. So you will move right of this 0 to state Q1. Correct? Now Q1 on Y. Q1 on Y is Y remains Y and you move towards right side. So now we are at XX Y Q1 on 1. What about Q1 on 1? Q1 on 1 is you convert it into y and move towards left side. So I have xx, right? And Q1, this one has become y now. And I should move left and Q2. What about Q2 on y? Just move left, right? So it will be x Q2, x, y and y. So what about Q2 on X? You can see here X, X, R and Q naught. So X is as it is and you move towards right and you make it as Q naught. What about Q naught on Y? Change the state to Q3 and move towards right. Correct? So from here, so x will remain as it is. Y also you are not going to change. So y will remain as it is. You are going to move right side and going to change the state to Q3. So this is my, I'll add blank here. Okay. Now what about Q3 on Y? Just move right. So XX, YY and I moved right. The state is still Q3. And if I get a Q3 and blank, right? Then what I'm going to do, go to the acceptance state. So blank I'm not going to change. I just go to Q4. So once I go to Q4, from Q4 no transitions. This has to be accepted because it's equal number of zeros and equal number of ones. Okay. Now let us see for unequal number of zeros and ones what happens. Okay. Let's take the input as 0, 1, 1. We always start at Q naught, right? What about Q naught on 0? Let me just, all right. So let us start again. Okay. Let us start with where our starting state is Q naught. Let us have 1, 0 and 2 ones. All right. So Q naught on 0, replace it by X, move towards right, change the state to Q1, right? So I moved from here to right. Q1 on 1, you can see here, replace it by Y, move towards left and go to state Q2. So I was here, so I'll replace that 1 as Y, move towards left here and then make the state to Q2. Okay. Q2 on X. Q2 on X, you can see X will remain as it is, but you move towards right and make the change state to X. Sorry, Q naught, right? So X will remain as it is. I move to right, change the state to Q naught. Okay. So I'm left with Y and 1. What about Q naught on Y? You can see here. If it's Q naught on Y, keep it as it is and move towards right. So I have Q naught and 1. Now we haven't written anything for Q naught on 1, isn't it? Q naught on 0 is there, X is there and 1 is there. So it halts here and this will be rejected. Why this will be rejected? Because when we designed the Turing machine, Q naught on 1 transition is not there, isn't it? So you can write it as delta Q naught on 1 is undefined. So this will be rejected. Okay. Let us, here we took more ones than zeros. Let us take one more example where we have more zeros than ones. Okay. More zeros than ones. So let's start with Q naught. Let's have 2, 3 zeros and a 1. Okay. And then we'll have obviously blank. Q naught on 0, we already know it will be X. I change the state to Q1. Correct? Next, Q1 on 0, you'll just keep it as 0 and move towards right. So 0, Q1, 0, 1, blank. Again, Q1 on 0 is same. That is, you move towards right, right? Now Q1 on 1. So Q1 on 1 is you replace 1 by Y. So 0, 0. And this 1 is replaced by a Y. After that, you move towards left and you make it as Q2. So it will be Q2 moving towards left. So Q2 on 0, you can see you just move towards left, right? So I got 0. So Q2 moves towards left. Again, it's Q2 on 0. So I move towards left. Now it is Q2 on X. So Q2 on X is just move right and make it as Q naught. So X Q naught 0 0 Y and then a blank. Now Q naught on 0, replace it by X and make it as Q1. Correct? Now you can see Q1 on 0, just keep it as 0 and move towards right. Correct? Now Q1 on Y, again you keep it as Y itself. You move towards right. Now you can see there is no transition from Q1 to blank. We have for 1 Y as well as 0 Y and 1. So again this will be rejected because there is no transition from Q1 or Q1 when the input is blank. Okay. I hope you understood this. So in a nutshell, how did we design this? So the question was to accept strings which have equal number of zeros and equal number of ones. So the logic was, whenever you find a leftmost zero, replace it by x and start moving towards right till we find leftmost 1. And then we replace this 1 by y and we start moving backwards, actually till we get an x. Once we get x, we move towards right in search of a 0, that is leftmost 0. So again, on finding this leftmost 0, we are going to continue this same step. Okay. So we are moving backwards and forth, front, right? And we'll stop when we have no more zeros or ones. If we have no more zeros and ones and we get a blank, then we move to the final state. And we will not write any transition for more zeros than ones or more ones than zeros. So keeping that in mind, we started with the 0, Q0, right? And as I said, if you get a 0, replace it by x and move towards right. Change the state to Q1. If you get any more zeros after the first 0, you just keep moving towards right. No change in state. Similarly, if you get 1 after the zeros, you change the state to Q2, replace 1 by y, okay, right, and move towards left. Once you move towards left, you might encounter either 0 or you might encounter y. If you get 0 or y, we just keep moving towards left, that's all, okay. And when you are moving towards left, if you get x, that means after that if there is a 0, that is the leftmost 0. So if you get x, we don't do anything for the x, we just move towards right, assuming we may get a 0. Okay. Suppose we don't get 0. So when we won't get 0, something like that, isn't it? Like this, or maybe something like if extra ones are there, something like this. In these cases, when from x you move towards right, you won't have 0, isn't it? So that's why what we do is from Q0, okay, if there are no more zeros, then what will I do? If I find a y, I'm just going to move towards right. As you know, if you get x, I just move towards right till I get a y. Okay. So if you get a y, you just move in search of a blank. For every y, you are moving towards right. So this is the leftmost x. And after this, I am searching for a 0. And if I don't find a 0, I'll find y. If I find y, I move towards right till I get a blank. If I get a blank, I go to final state. If I get a 1, I'm stuck because I haven't written anything for that. Okay. I hope you have understood today's class. And I'll continue tomorrow with one more design, like 1 power n, 2 power n, and 3 power n. Equal number of A's followed by equal number of B's followed by equal number of C's, or equal number of zeros followed by equal number of ones, equal three variables, same question. Okay. So we'll do this tomorrow. All right.